Good morning, students. This is the fourth video of chapter 2 is matter around us pure. Students, I have already explained you many physical processes that describe you how they can separate mixture. Now, this is the last process of this chapter. So, let's move to our first topic, that is to obtain pure copper sulfate from an impure sample. Impure copper sulfate can be purified by the method of crystallization. To obtain pure copper sulfate, this is done as follows. Take about 10 grams of impure copper sulfate and dissolve it in minimum amount of water in a china dish to make copper sulfate solution. After that, filter the copper sulfate solution to remove insoluble impurities. Heat the copper sulfate solution gently on a water bath to evaporate and obtain a saturated solution. This can be tested by dipping a glass rod in hot solution from time to time. When small crystals form on the glass rod, the solution is saturated. Clear? Now, then stop heating. Allow the hot saturated solution of copper sulfate to cool slowly. Crystals of pure copper sulfate are formed. Just see the diagram second. Impurities remain behind in the solution. Separate the copper sulfate crystals from solution by filtration and dry it. So, the question arises is, what is crystallization? Crystallization is the process of cooling a hot concentrated solution of a substance to obtain crystals. Is called crystallization. So, the process of crystallization is used to purify a large number of water-soluble solids. For example, the common salt obtained from seawater is an impure substance, having many impurities in it. So, common salt is purified by the process of crystallization. An impure sample of alum is also purified by crystallization. Crystallization is a better technique than evaporation to dryness because of the following reasons. Number 1, some solids like sugar decompose or get charred on heating to dryness during evaporation. There is no such problem in crystallization. Second, the soluble impurities do not get removed in the process of evaporation, but such impurities get removed in crystallization. Now, applications. Purification of salt that we get from seawater. And second, separation of crystal of alum from impure samples. Clear? Thus, by choosing one of the above methods according to the nature of the components of the mixture, we get a pure substance. With advancements in technology, many more methods of separation technique has been devised. Now, our next topic is physical changes. There are some changes during which no new substances are formed. On the other hand, there are some other changes during which new substances are formed. So, on the basis of whether new substances are formed or not, we can classify all the changes into two groups, that is, physical changes and chemical changes. Let us start with the physical changes. Those changes in which no new substances are formed are called physical changes. In the change or in a physical change, the substances involved do not change their identity. They can be easily returned to their original form by some physical process. This means that physical changes can be easily reversed. So, the changes in physical state, size, and shape of a substance are physical changes. Some common examples of physical changes are: number one, melting of ice, freezing of water, boiling of water, condensation of steam, making a solution, glowing of an electric bulb, and breaking of a glass tumbler. These physical changes are the examples of it. So, our first example, when ice is heated, it melts to form water. Let's see the diagram first. Though ice and water look different, they are both made of water molecules. Thus, no new chemical substance is formed during the melting of ice. So, the melting of ice to form water is a physical change. Second, see the diagram B. When water is heated, it boils to form steam. Though steam and water look different, but they are both made of water molecules. Thus, no new chemical substance is formed during the boiling of water. So, boiling of water to form steam is a physical change. When steam is cooled, it condenses to form water. So, the condensation of steam to form water is also a physical change. Let's see the third diagram or third example of physical change. When an electric bulb is switched on, an electric current passes through its filament, and the filament of bulb becomes white hot and glows to give light. When the current is switched off, the filament returns to its normal position and the bulb stops glowing. No new substance is formed in the bulb during this process. So, the glowing of an electric bulb is a physical change. Students, note that the physical changes are temporary changes which can be reversed easily to form the original substance. For example, the melting of ice to form water is a temporary change. We can reverse this physical change easily by cooling water to form the original substance, that is ice. Some more examples are of physical changes, that is sublimation of a solid, making of soda water by dissolving carbon dioxide in water, rotation of a fan, tearing of paper. Now, chemical changes. Chemical changes are those changes in which new substances are formed. In a chemical change, the substance involved change their identity. They get converted into entirely new substances. And the new substances usually cannot be returned to their original form. This means that chemical change are usually irreversible. Some common examples of chemical changes are burning of a magnesium wire, burning of paper, rusting of iron, ripening of fruits, formation of curd from milk, and cooking of food. So, some of these chemical changes are discussed. Now, just see the diagram first. If we burn a piece of paper with a lighted matchstick, what happened? Then entirely new substances like carbon dioxide, water vapor, smoke and ash are produced. So, the burning of paper is a chemical change. Rusting of iron, ripening of fruit, these are the examples of chemical change. The chemical changes are permanent changes which are usually irreversible. For example, the burning of paper is a permanent change which cannot be reversed. Why? This is because we cannot combine the products of burning of paper to form the original paper once again. Some more examples of chemical changes are burning of candle, burning of charcoal, burning of fuels like coal, wood and LPG, burning of incense stick, growth of a plant, cutting of trees and digestion of food. During all these changes, new chemical substances are formed. Student, please note that chemical changes are also known as chemical reactions. The following diagrams show a physical change and a chemical change which take place in the kitchen of our homes every day. Just see the diagrams. Here, the rolling of roti out of dough is a physical change, but the baking of roti on a gas stove is a chemical change. Understand? Now, what are the types of pure substances? On the basis of their chemical composition, substances can be classified either as elements or compounds. Let's start with the elements. An element cannot be split up into two or more simpler substances because it is made up of only one kind of atoms. This gives us another definition of an element which can be stated as follows. That is, an element is a substance which is made up of only one kind of atoms. For example, copper metal is made up of only one kind of atoms called copper atoms. So, copper metal is an element. Just see the figure. The atoms of different elements differ in size and composition. There are 115 elements known at present, out of which 92 elements occur in nature, while the remaining 23 elements have been prepared artificially. Students, every substance in this world is made up of one or more of these elements. Some of the common elements are hydrogen, helium, oxygen, nitrogen, bromine, iodine, chlorine, gold, zinc, iron, silicon, tin, mercury, etc. Even diamond and graphite are also elements. Elements can be solids, liquids, or gases. Some elements are solids, some elements are liquids, whereas other elements are gases at the room temperature. For example, sodium and carbon elements are solids, mercury and bromine elements are liquids, whereas hydrogen and oxygen elements are gases. at the room temperature. Most of the materials around us are made up of by the combination of two or more elements. For example, water is a common material which is made up of two elements, that is hydrogen and oxygen. Students, 26 letters of the English alphabet combine in various different ways to make a very large number of words. In the different or in the same way, a few elements combine together in various different ways to make an extremely large number of materials and objects. Even the human body is made up of complex compounds formed by the combination of only certain elements. Now, metal, non-metals and metalloids. On the basis of their properties, all the elements can be divided into three groups, that is, metals, non-metals and metalloids. We will now discuss these three groups of elements in detail one by one. Let us start with metals. Metals. A metal is an element that is malleable and ductile and conducts electricity. Some of the examples of metals are iron, copper, magnesium, zinc, aluminium, silver, gold, platinum, etc. All the metals are solid except one metal, that is mercury, which is a liquid. Now, the properties of metals. Metals, first property, that is, metals are malleable. This means that metals can be beaten into thin sheets with a hammer without breaking. Gold and silver metals are some of the best malleable metals. Aluminium and copper metals are also highly malleable metals. All these metals can be beaten with a hammer to form very thin sheets called foils. For example, silver metal can be hammered into thin silver foils because of its high malleability. Now, second property, that is, metals are ductile. This means that metals can be drawn or stretched into thin wires. All the metals are not equally ductile. Some are more ductile than the others. Gold and silver are among the best ductile metals. For example, just 100 milligrams of a highly ductile metal like silver can be drawn into a thin wire about 200 meters long. Thus, ductility is another important characteristic property of metals. Now, the third property, that is, metals are good conductors of heat and electricity. This means that metals allow heat and electricity to pass through them easily. Metals are generally good conductors of heat. Silver metal is the best conductor of heat because it has the highest thermal conductivity. Clear? Now, the fourth, metals are lustrous or shiny and can be polished. For example, gold, silver and copper are shiny metals and they can be polished. The property of a metal of having a shining surface is called metallic luster, or we can say chamak. For example, gold and silver are used for making jewelry because they are bright and shiny. Fifth, metals are generally hard except sodium and potassium, which are soft metals. Most of the metals are hard, but all the metals are not equally hard. The hardness varies from metal to metal. Most of the metals like iron, copper, aluminium, etc. are very hard. They cannot be cut with a knife. But there are some exceptions. Sodium and potassium are soft metals which can be easily cut with a knife. Now, non-metals. A non-metal is an element that is neither malleable nor ductile and does not conduct electricity. Some of the examples of nonmetals are carbon, sulfur, phosphorus, hydrogen, oxygen, nitrogen, chlorine, bromine, iodine, helium, neon, argon, krypton, xenon, etc. Diamond and graphite are also nonmetals, and they are the allotropic form of carbon. All the nonmetals are solid or gases except bromine, which is a liquid nonmetal at room temperature. Now, properties of nonmetals. The first property is nonmetals are not malleable. They are brittle. This means that nonmetals cannot be beaten into thin sheets with a hammer because nonmetals break into small pieces when hammered. For example, sulfur and phosphorus are solid nonmetals which are not malleable. They cannot be beaten into thin sheets with a hammer. Thus, we cannot get thin sheets from non-metals. Second, non-metals are not ductile. This means that non-metals cannot be drawn into wires. They are easily snapped on stretching. For example, sulfur and phosphorus are non-metals and they are non-ductile. Third, non-metals are bad conductors of heat and electricity. This means that non-metals do not allow heat and electricity to pass through them. For example, sulfur and phosphorus are non-metals which do not conduct heat or electricity. Many of the non-metals are in fact insulators. There are, however, some exceptions. Diamond is a non-metal which is a good conductor of heat. Now, fourth property, that is, non-metals are non-lustrous or non-shiny. They are dull in appearance. Non-metals do not have luster or chamak, which means that non-metals do not have a shining surface. The solid non-metals have a dull appearance. For example, sulfur and phosphorus are non-metals which have no luster. Fifth, non-metals are generally soft, except diamond, which is extremely hard non-metal. Most of the solid non-metals are quite soft. They can be easily cut with a knife. For example, sulfur and phosphorus are solid non-metals which are quite soft and can be easily cut with a knife. Now, metalloids. There are a few elements which show some properties of metals and other properties of non-metals. For example, they look like metals but they are brittle like non-metals. They are neither conductors of electricity like metals nor insulators like non-metals. They are semiconductors. The elements which show some properties of metals and some other properties of non-metals are called metalloids. Their properties are intermediate between the properties of metals and non-metals. Metalloids are also sometimes called semi-metals. The important examples of metalloids are boron, silicon, germanium, etc. Now, compounds. A compound is a substance made up of two or more elements chemically combined in a fixed proportion by mass. For example, water H2O is a compound made up of two elements, that is hydrogen and oxygen, chemically combined in a fixed proportion of 1:8 by mass. Similarly, common salt, that is sodium chloride, and the chemical formula is NaCl, is a compound made up of two elements, sodium and chlorine. Another example, marble, or we can say calcium carbonate, CaCO3, is a compound made up of calcium, carbon and oxygen elements. Just see the figure A. Some more examples of compounds are ammonia, NH3, carbon dioxide, CO2, ice, H2O, steam, H2O, chalk, calcium carbonate, CaCO3, etc., copper sulfate, CuSO4. Compounds can be further divided into three classes, that is acid, bases and salts, on the basis of their properties. For example, sulfuric acid is an acid, sodium hydroxide is a base, whereas sodium sulfate is a salt. We will now take one example to understand the characteristic properties of a compound. For example, by mixing iron filings and sulfur powder, we can obtain a mixture without any chemical reaction taking place. So, we can still see the yellow sulfur in the mixture and we can pull away iron filings with a magnet. But if we heat the mixture of iron filings and sulfur powder taken in a boiling tube strongly with a burner, a chemical reaction takes place and a new chemical compound is formed. The new chemical compound formed is iron sulfide, which is black in color. It contains sulfur, but we cannot see any yellow color of sulfur. It contains iron, but we cannot pull away this iron with a magnet. Students, this is your classwork of chapter 2, is matter around us pure. Let's move to the question and answers. Our first question is, what type of mixtures are separated by the technique of crystallization? As you know, the mixtures containing solids in which the impurities may be either less soluble in the solvent or more soluble in the solvent than the solids are separated by the technique of crystallization. For example, the impurities present in impure copper sulfate, common salt and alum, etc. can be separated by the technique of crystallization to obtain the respective pure substances. Now, question second. Classify the following into elements, compound and mixtures. Here, few examples are given. You have to classify it. The examples are sodium, soil, sugar solution, silver, tin, silicon, calcium carbonate. So, as you know, elements sodium, silver, tin and silicon are the elements. Calcium carbonate is compound. Soil and sugar solution are mixtures. Now, question 3. What is a physical change? Give 2 examples. Physical changes are those changes in which no new substances are formed. It is reversible. The examples of physical change are melting of ice, freezing of water, tearing of paper, etc. Okay, clear? Now, let's move your homework assignment of chapter 2 is matter around us. So, let's move to the questions. Question first, which of the following are chemical changes? Growth of a plant, rusting of iron, cooking of food, mixing of iron, peelings and sand, digestion of food, freezing of water, burning of candle. As you know, students, chemical changes are those changes in which new substances are formed, or we can say which are not reversible. So, growth of a plant, rusting of iron, cooking of food, digestion of food, and burning of candle are the examples of chemical changes. So, they are chemical changes. Question 2. What is a chemical change? Give 2 examples. I already explained you. A chemical change are those changes in which new substances are formed or which are irreversible. For example, burning of candle, digestion of food, rusting of iron, ripening of fruit, etc. These are the examples of chemical changes. Let's move question 3. Define a compound. Give 2 examples. A compound is a substance made up of 2 or more elements that chemically combine in a fixed proportion by mass. For example, water is a compound made up of 2 elements, hydrogen and oxygen, and it is chemically combined in a fixed proportion of 1:8 by mass. Similarly, common salt is a compound made up of 2 elements, that is sodium and chlorine. Now, question 4. Name a metal which is soft and a non-metal which is hard. So, the answer is a metal which is soft, that is sodium or potassium. And a non-metal which is hard, the answer is diamond. Question 5. Define an element. Give 2 examples. An element is a substance which is made up of only one kind of atoms. For example, copper metal is made up of only one kind of atoms called copper atoms. So, copper metal is an element. Similarly, iron metal is made up of only iron atoms. So, iron metal is also an element. I hope you have to clear all the points.